Hello all you super geniuses out there, and welcome to another video lecture from Super Genius 99. We're going to do function notation. I think it's the third one in a quick series, which doesn't imply that we won't do function notation another time, but this will probably be all the function notation for this season. Okay, so we want to find the domain of the function that is given. Okay, so let's look at the first one. F of x equals x squared plus 3. So when someone says find the domain, they're talking about what are all the possible y values. Give me a set that represents all possible y values. And x values. Domain is the x values. Apologize for that. Give me a set of all possible x values. And in doing so, what you're really looking for is you're kind of looking up on your graph here and you're saying, okay, where is the x value undefined? In other words, is there anything that will make the x value undefined or not a real number? Okay, and there's usually two primary cases, right, where it's undefined or not a real number, and one of them is a 0 in your denominator, right? We can't have 0 in our denominators because that'll make our function undefined. And then the second one, this isn't the only one, these are primary too, and that is a negative under a radical. Sorry, I meant to say RAD, but a negative under a radical. So those are the two primary things that we want to look out for. Okay, so let's look at the first one. Remember, when we're looking for the domain, we're really looking for is there constraints on the x values, such as a 0 in the denominator or a negative number in the radical. Well, if you notice the first one, it's not a fraction, so it doesn't have a denominator, and there are no radicands, so really all possible real numbers will work for this. So there's several ways to write all possible real numbers. I'm going to use the negative infinity to positive infinity set, and that will be all possible real numbers. Okay. How about the second one? Is there any conditions that we've listed so far that would make x, the output of that function undefined or not a real number? And you notice it has a radical, so we have to watch out for a negative in the radical. So what would make the bottom part, what would make this second function here have a negative on the radical? Well, in order to have a negative on the radical, what's under the radical would have to be less than 0, right? Okay, because you can have 0 on the radical, you just can't have negative. So then we solve for x squared minus 9 is less than 0, and then you'll notice you'll get x squared is less than or equal to 9, because I added 9 to both sides. And if I square root to both sides, I have x has to be less than, because you get that plus and minus, so we should do it this way. Square root of x, and then the square root of 9 plus and minus. And so x has to be, I think it's less than, hold on a second, guys. Okay, so x cannot be less than 3 or greater than your negative 3. So x cannot be in between the values of negative 3 and a positive 3, because that will cause the less than 0 under the denominator. I'll cause a negative denominator. And so how do we write that in function notation? We'll say in set notation, negative infinity to negative 3, comma, positive 3 to infinity. And notice how we're using the semicolons. Yeah, not the semicolons, but notice how we're using the parentheses. Parentheses meaning we don't include the negative 3. So we can have negative 2. Sorry, we can have negative 4, negative 5, negative 6, but not negative 3. Here we can have 3.1, 3.2, 5, 7, but we can't have a positive 3. So the domain for the square root of x squared minus 2 is negative infinity to negative 3, positive 3 to positive infinity. Okay, next, what is the domain? Of course, this is t, it's not x, but what is the domain of t over t minus 4? So we just have to ask ourselves, do we have radicals our denominator, our fractions? Yes, we do. So we have to make sure our denominator does not equal 0. So in this right here, we just have to make sure t minus 4 does not equal 0. Okay? And the only way this right here can equal 0 is if t equals a 4. So the domain for s of t, t over t minus 4, is all values except for positive 4. So how do we represent that? Negative infinity to positive 4, not including positive 4, comma, our union, if you want to use the union, positive 4 to infinity. So that is your domain for this function here. Let's do the next one. And what is the domain here? Once again, we have a fraction, so we have to make sure the denominator does not equal 0. So r squared minus 4 cannot equal 0. And r squared minus 4 is composed of r plus 2, r minus 2 cannot equal 0. Okay, so that means r plus 2 cannot equal 0, and r minus 2 cannot equal 0. So then r cannot equal negative 2, and r cannot equal a positive 2. Because here I subtracted 2 from both sides, there I added 2 to both sides, right? Okay, so what is your domain here? It's all values except for negative 2 and positive 2. So how would you represent that? So negative infinity to the negative 2 union, negative 2 to positive 2 union, positive 2 to infinity. So it's negative infinity to negative 2. Okay. Union, so we're skipping everything in between negative 2 because we can't have negative 2 on the dot. And then from negative 2 to positive 2, but not including negative 2 and positive 2. And negative 2 to infinity. Alright, so this concludes our video lecture on domain of functions in the function notation series. And thank you for watching.